The claim is that I'm an 80% free throw shooter. To prove my skills, I shoot 50 free throws, but I only made 32 that day. Am I exaggerating about my skills? Let us find out. So before we dive into this, let's revisit these terms again. What's the population we're investigating here? Proportion of what? Well, that would be your parameter. So we can do that. P is the proportion of free throws made. But the population is all of Dobbs' free throws, right? Obviously, we're not going to see all of them, but we're trying to estimate that. Okay. So what was the sample that we took? 50 free throws. And the statistic, that's the p hat, right? Out of 50, I made 32, which translates to 0.64, right? Now, obviously, 0.64 is not 80%, is it? Now, there's two possible logical reasons why I didn't make 80%. What's one of those reasons?
You're a liar.
I'm lying. Okay. Dobbs is exaggerating. All right. What's the other reason? Could be. Just a bad day. Yeah, just a bad day, right? Just a bad day. A bad day of basketball. Just a bad day. One of those two things is true. We got to figure out which one is true. So the question becomes, okay, if I really am an 80% shooter, is it likely that I could shoot that bad? Is that a possibility by random chance?
Yes.
That's what we're going to investigate. Now, that's what we're going to use this applet for, okay? And we're actually going to accomplish like all of this stuff right here with this applet online. All right, and you're going to see it as we do it. So I'm going to switch screens, and we're going to come back to it, okay? Like Kendall said, there are no dots on the dot plot lower than 64%, are there? Nothing. So that's going to be a conversation piece in a moment, because here's 64%. No dots here. All right. Now I'm going to switch back to my iPad. So, okay, there we go. Now, let's think about this. What does each dot represent on this dot plot? The proportion, remember it's proportions? No, it's not an average. The proportion of shots made out of 50, right? Portion of shots made out of 50 by an 80% free throw shooter. Remember I told you that little robot is built in with an 80% free throw rate? It wasn't just 50-50, it was 80% the way she was programmed. So this is based on an 80% shooter. Okay? Now, if we go to the top of the next page, it says, each dot represents a proportion of free throws made out of 50 free throws shot by Mrs. Dobbs. Is that a true statement? Or what is it missing? Well, it's just defining what the dot is, so what each dot represented. Well, do we know that I'm an 80% shooter?
Yeah, it's like missing the percent.
Oh, I see. It's
I think you're right.
made 80%, not you.
Yeah, it's not shot by Ms. Dobbs. This is shot by an 80% shooter. Is that what you're getting at, Tommy?
Yeah, that's what I understand.
Yeah. It's not by me because we're trying to prove if I'm exaggerating or not, right? So then 8 says, what percentage of the dots represented a percent of 64 or less? What did we see? 0. Big fat goose egg. None of them did. None of them did. So she drew the right conclusion. She got there fast. Now, interpreting this percentage. This percentage is what we're going to refer to in this chapter and forever is called the p-value. Not p-hat, not p for proportion, but this p stands for probability. All right? Probability value. And here's how we interpret this. This sentence kind of gets wordy, but you can do this. So it starts out with the assumption, okay? Assuming Dobbs is an 80% free throw shooter. So there's the assumption we're making. There is a 0% chance of getting what? A sample. And instead of saying sample, I'm going to use symbols here. I'm going to use a p-hat of 0.64 or lower. Didn't we see that on the dot plot? Or lower. And here's the magic phrase. By random chance alone. By random chance alone. So it feels a little wordy, doesn't it? This phrase, by random chance alone, is really actually very important when you interpret the p-value. And so it follows the same structure every time. The words change because the questions change, right? But just stop and think. Assuming whatever is true, this is what we're going to call the null hypothesis, the essential claim, okay? Assuming that's true, there's a p-value probability of getting what? A sample of whatever the question's given us, or higher or lower. You'll see some of this in a little bit. But then we always end it with by random chance alone. Okay? Now, that's your first pass at this, so it doesn't seem too bad. But you're gonna see this process repeated a lot. All right? Now, then the question is, based on this, does the observed 64% give convincing evidence that I'm exaggerating? Is there convincing evidence? Or is it plausible that I just had a poor performance that day? Well, what did we see? After 50-something trials, it never got that low, did it? Never, ever got that low. Do you remember what the magic percentage was that we used before Christmas about, we would say it was suspect if it was lower than?
5%.
Good, 5%. Here it comes again. That 5% is what we will be calling our significance level. That's how we decide is it significant, okay? So the way that we would phrase this, and we would say since our p-value, 0% is less than 5%, it's our significance level, we have convincing evidence that Ms. Dobbs is exaggerating. Okay? That's what we have to say. We have convincing evidence that I'm exaggerating because, like she said, it never even happened in all those simulations, right? So far, so good? So look, what do we have to take away from this simulation? It's just these three things down here. State an appropriate hypothesis. Well, what was our hypothesis here? We'll get these symbols in a minute, but the null hypothesis looks like this. It's H null. It's not H0, not HO, it's H null, so we just say null hypothesis. The null hypothesis was that I'm an 80% shooter. But the alternative was, okay, what did our sample say? 64%? That's definitely less than 80%, right? So the alternative is that I'm less than an 80% shooter, and we proved it with our p-value. All right, so state an appropriate hypothesis, and we'll do more of this in the next one. Interpret p-value, and then make a conclusion.